Good evening. Welcome to the 11th week of the live interaction session for the course Multimodal Urban Transportation Systems. The instructor is Professor Orkopal Goswami and I am Shankhadeep Pramanik from IIT Kharagpur. So, in this week we were discussing about urban transport and sustainability. We are already discussing about the multimodal concept of the transportation planning, and in these lectures we have also discussed different aspects of multimodal transportation. So we started with multimodal transportation environment and how uh, what should be the concept behind multimodal transportation and how the system should be planned in a integrated manner so that the different aspects like accessibility or mobility, these things are also intact mm, with the system, with the overall planning concept. And we have also discussed about different indicators or measurement indices that will be best suited to know that whether the public transportation system is performing better or not. This multimodal transportation systems is performing better or not, and whether it will influence people to shift from their private mode to multimodal transportation. These things were discussed. Then we also, similar to other level of service, there are also multimodal level of service, and it was done based on HCM 2010, that we have discussed, and with some example also. We continued our discussion with the transfer facility, which is one of the important aspect, so that more and more people shift towards the multimodal transportation. This is basically the how easily they can access different facilities, and which will actually increase the efficiency of the overall efficiency of the system. And there we have discussed about the designing principle, and the how should be the stations size, or what facilities should be there for the different transfer stations or terminals, or different transit centers. These things were discussed, and also we have given some checklist, like what should be evaluated during the design review process. And then we shift to park and ride facility planning. There it is also one of the major aspect of this multimodal planning, so that people can uh, mm, park their vehicle, and they can choose a particular mode of transportation from a particular location. And here we have discussed about different prioritization methods like analytic hierarchy process. Similar to that, there are other method also, but we have discussed only this AHP process. uh, so with that we have concluded this week 11. Now I shall proceed to the question answers. So first one, what is volume to capacity? The ratio between the existing volume to the maximum capacity of cars on the facility, ratio of segment length through movement travel time, the traffic speed on the segment when free flow conditions exist and speed is uninfluenced by signal spacing. So which of these is uh, volume to capacity ratio? You can answer in the chat box. Correct, it is the ratio between existing volume to maximum capacity of cars on the facility. This is basically volume by capacity ratio. Next is, which of the following is a type of passenger information system? Static, variable, real time, all the above. Correct. We have discussed about different these passenger information systems, and there we have discussed static signs like permanent signs and variable signs or real-time signs. So these all are important not only for multimodal transportation facility at station facility, but also in different locations uh, of their throughout the stretch of the multimodal planning. These can be used, especially the real time or variable signs can be used for better so that commuters can get a better idea about like that time required or the arrival time of different bus. So uh, all of these are passenger information system. Next is, determine the travel time ratio, level of service, and interconnectivity ratio for a metro system between two origin destination pairs whose riders had the following average value of travel times. The commuter undergoes multiple access and egress trips to use the metro system. Calculate the two decimal places. So travel time is given, the average value is given. Now you need to calculate the travel time ratio, level of service, and interconnectivity ratio. It is basically the travel time by public transportation divided by public transportation divided by travel time in car, and level of service is basically out of vehicle travel time divided by in vehicle travel time. And this is interconnectivity ratio is total time of access plus egress divided by total travel time. So from this value you can calculate. Right, C is the correct answer. So mm, the travel time ratio is travel time by public transport divided by travel time by car. Then level of service is out of vehicle travel time divided by in vehicle travel time, and interconnectivity ratio is access plus egress time divided by total travel time. And travel time attribute and values are given for access time, egress time, transfer time, etc. So let's calculate first what is the total time taken by public transportation mode, which is the total access time accessing in a public transportation, egress time egressing from the public transportation, and in vehicle travel time. So that will be the total time, which is given as access time 10, egress time 16, and the in vehicle travel time is 28. So total 54 minutes. It is time taken by public transportation. Now also it is given that time taken when journey is done by car is 30 minutes. So from there you can calculate travel time ratio, that is travel time by public transport divided by travel time by car. So travel time by public transport is 54 as we have calculated, and travel time by car is 30, so the ratio will be 1.8. Now level of service, that is out of vehicle travel time divided by in vehicle travel time. Now in vehicle travel time we already know that it is given 28 minutes, and out of vehicle travel time is the summation of access time plus egress time, that is which is not inside time which is not spent inside the vehicle. So it is access time and egress time, it will be total 26 minutes. So the value is 0.92. And interconnectivity ratio, it is the total access plus egress time that we have calculated as 26 minutes, and the total travel time, that is 54 minutes total travel time in public transportation. So if we uh, divide it divide these two, then we will get 0.48. So 1.8, 0.92 and 0.48. So option C will be the correct answer. Okay, this one I guess it will be 0.48. Right, it will be 0.48, sorry. Now next question, for transit and bicycle, a level of service score of less than 2 corresponds to which of the level of service level? A, B, D or F? So it is basically for bicycle, the less level of service score, that is a better one. So for less than 2 score corresponds to level of service of A. So option B will be the correct answer here. And there are different ranges are given, and greater than 5 is a very bad LOS in this context. Next is determine the automobile level of service for a west to east travel direction So this is the travel direction from west to east of the facility using the HCM 2010 methodology. Individual segment length, base free flow speed, and travel speed for the facility is given below this table. For different segment, the length is given, base free flow speed is given, and travel speed is also given. Note that V by C ratio for the facility is 0.72. So from that you need to calculate the automobile level of service, and you can also use this table. So it may take some time to calculate. You can just calculate and then I'll discuss the question. Correct, it will be level of service of F. So we first need to determine the base free flow speed, and we know the length and the different base free flow speed for different segments. From there we can just sum the length of the segment, so total 1.8, 0.8 and 0.98, this one, and in the denominator the length we already know, and the base free flow speed is also known to us, these three. So we, from there we can calculate the denominator, and the base free flow speed of the facility will be 53.6 kilometer per hour. Now travel, we need to similarly calculate the travel speed. Individual travel speed for three segment is also given, and similar to the base free flow speed of the facility, we have to calculate the travel speed of the facility, and it will come as 12.54 kilometer per hour. Now we have not consider this step 3, that is determination of the spatial stop rate, since it is optional, and therefore we don't calculate it. And now the automobile level of service is travel speed as a percentage of the base free flow speed, that is the value obtained in this second step divided by the value obtained in this first step. So it will basically come as 23.4. Now travel speed as a percentage of the base free flow speed for the facility is in this axis, And also there is given that level of service by critical volume to capacity ratio, and our critical volume to capacity ratio is already given in the question for the facility is 0.72, which is less than 1. So we will consider this table only. If it is greater than 1, then we can consider this one, but it is less than 1, so we will consider these values. And our travel speed as a percentage of base free flow speed is 23.4, so which is less than 30. So our level of service will be F. So option D is the correct answer, level of service F. So we need to calculate the free flow speed for the facility, travel speed for the facility, and then we have to divide, we have to convert these values, the travel speed as a percentage of base free flow speed, and from there, from this table we can calculate which level of service is the facility is. Next question, which of the following input data element falls under traffic characteristics data category? Number of through lanes, total walkway width, excess wait time, width of the bicycle lane. Yes, once as the table suggests that if it is greater than 1 volume, it is like volume is more than capacity. So what this suppose this road, what how many number of vehicle it can accommodate, the volume is more than that. So when it is greater than 1, then all the cases the level of service is F. That's why otherwise it would, in this case it is different, like suppose capacity, it can there can be 1,000 vehicles or 1,000 number of vehicles, but if the volume is more than 1,000, suppose 2,000, so it will obviously cannot accommodate. So the level of service will be F, and vehicles are will be in a jam condition. And if it is less than 1,000, then it can be different level of service can be possible.
Segment length is 1.8.
Yes.
Show the diagram.
This one.
Here it is specifically all around L1 1.8 meter. What is that 1.8?
This is this distance. This one.
L2.
This one is L1. This one is L2, and this one is L3. So it is the segment basically between.
It will be more, na? Actually.
Yes, the diagram is not drawn to the scale. This portion may be a bit more, and these two may be a bit shorter actually. But consider these values only. Okay. Next is, which of the following input data element falls under traffic characteristics data category? Yes, it is excess wait time. So it in this here we have discussed about different traffic characteristics, geometric characteristics, or performance measure for non-automobile users, and there this excess wait time is a traffic characteristics. So option C is the correct answer. Which of these is a limitation of conventional transportation planning? Impacts such as equity, indirect environmental impacts, etc. considered, doesn't favor roadway capacity expansion, does not supports automobile dependency, focuses on a limited set of impacts. It will be actually option D. So which of the following limitation, it is saying that limitation of the conventional transportation planning. So conventional transportation planning doesn't take into account the equity. That means considering every uh, type of producer, like in conventional transportation planning we are more focused for the vehicle automobile context, but as the transportation planning evolves we must taken care about the other road users like pedestrian or bicyclist. We cannot build such an infrastructure that will hamper them also. So in that context this equity comes, and the environmental impact is also one of the major concern right now. So traditional conventional transportation planning doesn't take into care about these things, but the multimodal planning can take these considerations. uh, and But the limitation is mm, uh, mm, okay, this one is also correct actually. uh, these these are actually difficult to quantify this equity indirect environmental impacts, but these are also limitation of the conventional transportation planning. And uh, it also focuses on a limited set of impacts. Conventional transportation planning also um, support a limited set of impacts. So these two are the correct answer here. Next is fill in this um, in the green transport hierarchy, these um, 1 2 3 and 4 you have to identify. Rest 3 are given. Right, one is the walking, second bicycle is given, two is the public transportation, three is the service and freight. This one is also given, IPT, intermediate paratransit, and then multi occupancy cars, that is carpools, then single occupancy car. This should be the hierarchy for green transportation. It favors more the affordable and efficient modes. Next is total service time divided by total travel time with respect to public transportation is referred as running index, passenger waiting index, interconnectivity index ratio, and travel time ratio. So we discussed about different ratios and sorry, travel time ratio is the related to travel time and it is basically travel time by public transportation and travel time by car. Now interconnectivity ratio is the access and it is related to more related to connectivity, so it is access and egress time divided by total travel time. Passenger waiting index is mean passenger waiting time, so it is more related to passenger centric, and passenger waiting mean passenger waiting time divided by frequency of the transportation service. And this one is running index, that is when the vehicle is running, so it is more related to total service time divided by total travel time. So it is basically running means it is moving or giving some service, so it is total service time divided by total travel time. Yeah, option A will be the correct answer here. Which of these is one of the primary level of analysis of highway capacity manual application? Operational analysis, design analysis, planning and preliminary engineering analysis, or all the above? Correct. There are uh, three levels of three primary levels of application, and it is mainly centered to operational analysis, which typically focus on current or near term conditions. So it is basically in operation condition. Then a design analysis, it is typically using HCM procedures to identify the required characteristics of a transport facility that will allow it to operate it at a desired level of service. So it is basically designing a transport facility in such a way to meet a certain level of service. And last is planning and preliminary engineering analysis, that is typically focus on future condition where it is desired to evaluate a series of alternatives quickly or when specific input values to procedure are known. So it is basically in planning level, design level and operation level. These three are the primary applications. So all the above options are correct. Next is 8 variables are used for developing transit LOS. Accept or reject statement. It will be rejected. There are actually transit LOS use 6 variable. These are actually the variables, and there are 6 variables are used for uh, developing transit LOS. So it is 6. Which of the following is most favored in M multimodal a level of service calculation? Pedestrian, bicycle, automobile and transit. Most favored. It will actually be pedestrian first. So M multimodal level of service favors pedestrians, followed by bicycle, followed by transit, and lastly automobile. So it will more favors on which is non-motorized, green, and sustainable mode. So pedestrian is the walking is the most. That's why walking is the most favorable for MLOS calculation. Which of the following hierarchy should be followed to give priority of access to transit customer? Correct. D will be the answer. Pedestrian, bicyclist, shuttles, and taxi. This should be the hierarchy for the access to transit customers. So more favor should be given to um, pedestrians or like non-motorized transportations, and least preference is given to the automobiles and personal vehicles. Next is accept or reject statement. Average wait time should be considered for sizing the shelter in passenger waiting area. Accept or reject. Correct. This will be accept. So the wait time must be considered for sizing the shelter in passenger waiting area. So the it will be easier for the passengers, and like the capacity will be known. Next is accept or reject statement. Three type of park and ride facilities are generally designed. So this statement will also be accepted. There are three types of park and ride facilities are there: local, remote, and peripheral. Peripheral is the edge of the CBD area, and remote is intercepting automobile trips near origin with excess bus or rail service to near to the CBD area, and local is serving as a collector, that is transit terminals like bus or metro stations. So these three type of park and ride facilities are there. Next is transit center is also informally known as bus stop, bus station, hub, transfer terminals. Correct. C will be the answer. It is commonly known as transit hub also. So that's all for this week. Only 1 week is remaining for the we will again meet on next Monday. If you have any question, you can post in the discussion forum also. Meanwhile, thank you for joining. In the slide, just let me show. This one. Okay, just let me check once what is given. Okay, just give me some time. I will just get the calculator and check it once. Then I will explain. Hello. Mm, Hello. Yes. Okay. Let's do. I guess we can do it. Take some time, and we can do it in the Excel actually. Mm. Next, let me put the. So the values given are 143 134. This value.
So if you put in decimal variable
Hmm?
or you change the variable to fraction.
This one. This one.
No, for the 0.14, I think you have to either change
Uh,
the variable to fraction or you put in decimal 0.25.
okay, it's better to go 0.25 like that.
It's still in it.
Why it is not?
I think it's the custom.
Which option you are saying?
Custom. No, it's just the arrow here. Yes, the arrow. No. Uh, yes, above them there is an arrow. Yes, you change the number of fraction. The fraction is down. Fraction is
Thanks. I didn't know that one.
not
Hmm, This one. Let me send it. Any idea why it is coming like that? 0. It shouldn't be 0. Yes. So I am just going step by step. So you have read this question, right? So here there are different metrics are given, and experts are giving their rating based on their judgment. So it is like pairwise they are doing. So if they are giving a certain number 4, then the corresponding this side column will be 1 by 4. So it is like a comparison, like that. If C2 is 1 by 5, C1 is 5 times more important than C2. Similarly, that means that C2 is 1 by 5 times important than C1. It is like the they are comparing between the two, like C1 is a element and C2 is a element. So they are saying that C1 is 5 times more than the C2. That's why this 1 by 5 or this side, like this side is 1 by 6, then this side will be 6. We can interpret it like that, and this is the main table. Now in the final, our goal is to select the best P&R location. There are different criteria available, and for all criteria there are 3 alternatives, A, B and C, and experts are ranked the criteria as well as the alternative here. Now if we go in the final develop weightage matrix, the criteria are given and there are some weights given here. Now how we can get the forget about this A, B and C and these values. Now just focus with this portion, and if we want to calculate these values, then how we can calculate it? We can calculate it through this matrix. Now what should we do? We have to column transform this one. So if I do it side by side, then what I have done, I have just taken this matrix, this one that is given one, this matrix. Now what I have done is I have sum each column. So first I have sum these values. I have summed these values and it is 3.17. Similarly, for every column I have calculate the sum. Now how they are getting this value? This is the actually we have divided each element here. If you see that we have divided this element by the column sum, then for this element we have divided this element by its column sum, this element by its column sum, similar to that, and ultimately from there we have got some matrix here. And now if we average it, average means here if we averaging this 3, 4, 5, 6 value, we are taking average. So if we average this one, then we will get this value of 0.305. Similarly for this table also, this table, and you can see the values, like it is almost similar. There are some difference in the point, but ignore it. So 305, 304 or 148.038, 141, 220, 146. So this is basically our weightage for different criterias. These all are TT, PV, LM, NMT. These all are criteria, and their weightage is given as 0.304. We have calculated it: 0.304, 148, 0.0382, 142, like that. These values we have calculated and put the values here. So this is the weight of the criteria TT, PV, LM, NMT. Now if we come to the alternative section, we can do the similar thing. We can for example, if we take the first TT value, let me calculate it. It is TT, and here A, B, C, this side also A, B, C, 1, 3, 2. By 3, similar to this one. So if you see that these metrics were given, that how they have ranked between each alternative for travel time or PV or LM. Now consider this only for travel time. These values are given 1, 3, 2, 1 by 3. Now again we have to column transform it, that is dividing each element with the respective. We have to first calculate the sum of this column. We are calculating the sum of the column, and we then have to divide each element by the column sum. This we are dividing it by column sum. This we are divided it by column sum. And finally what we have done, we have taken the average of these three values. Similarly for this one, the average of these three values, and we have got this value of 0.16, 0.59, 0.25, these values. So similar to that, we have calculated it for TT. We can calculate it for PV, LM, NMT, TI, FS. Now whatever value we have got, like 0.16, like we have got 0.16, 0.59, these values corresponding to A, B and C for travel time. So corresponding to travel time, we can put the value of A, B and C. Similarly, if you go for FS, then the value is 0.69, it is 0.69, 0.09, 0.22, 0.09, 0.22. These matrix we have to develop, the weighted matrix. So we have already, for different criteria, there are 6 criteria, 1 2 3 4 5 6. For 6 criteria we have got the values after column transformation. These values are the weighted values. So these values are the weights. So these values are the weighted values. Now for even every alternative, there are actually 3 alternatives for every criteria that we have. For their weight we have column transformed the criteria and got this weighted, and now we have developed this total matrix, this one. And again if we do the similar thing, and for now we have to actually weighted sum we have to calculate, that is we have to calculate these values. So how we can calculate? We can just multiply these values into this one, like for this one equal to, first one is 0.304 multiplied by 0.16 plus 0.33 into 0.148 plus here I guess these values are something is wrong with these values, but you have to just multiply these two values 0.16 into 0.304, 0.33 into 0.148, these two values, and add it sum, and the summation will be this value.
Okay, so I understand.
Okay.
So afterwards, we take the highest of the weighted between the alternative and the highest for the different type of transport
Yeah,
type.
yes, like the best value will be the answer, like the best alternative, and here for this one highest is this first one, travel time it is, and for this one it is the 0.376. So these two will be we have to take. Means from both side, for the travel time PV this weightage highest, and if you this from this side this value it is the highest among these six values, and for these three values it is the highest, so take alternative A. So travel time of alternative A will be the best P and R location. Means you have got the criteria and you have got the alternative also, which is the highest.
Okay, sir. Thank you very much.
And do you have understand the column transformation, like how we get the these values?
Yes. I understand.
Oh, okay then.
Thank
Thank you. Okay, there was a mistake. I accidentally put a minus sign. That's why it was not coming. Now it is 0.7 37654, similar to this one. We just uh, mm, multiply these values. Is there any other question, or you may leave now? Okay. Thank you for joining.